So today we are supposed to start on definition of terms. And if you look at the notes that I sent, we are supposed to look at various terms. And I think most of them, they have been shared here. What is a semaphore? So where we understand that a semaphore mostly assists in restricting access to shared resources. Remember that we have some processes that we can restrict from the users, which are not supposed to be accessed by the user. And within that, it's mostly where you only allow the execution through what you call the critical section, where the critical section is a section that is mostly used for a process to execute. Then we have another one, which is monitor, where a monitor is a synchronization construct that mostly allows the access of a process in the critical section. So where we are saying we only allow one execution of a process at a given time, we cannot allow two processes to execute. So the monitor will always make sure that there is in and out of the critical section. So which process is supposed to be in the critical section and which is supposed to be outside the critical section. So that is mostly the function of a monitor, because mostly we are looking at the shared processes or data that we have, and we cannot execute these jobs at the same time. Then we have a shell, which is now a primary interface between operating system and users. So in most cases, we have shell like e.g., we have corn shell, then we have born again shell, then we have zesh, shell, etc., which are mostly creating some platform that the users can be able to interact with. So the moment you're using an operating system, mostly this operating system is creating an interface that the user can be able to communicate with other users. And that's why we are saying the operating system is the most important program that is in the computer. The operating system basically runs the computer and allows other programs to run as well. Because now, if you are able to provide the shell, which we have said we have these shells, we are able now to provide a platform that the user can use a keyboard, can use a mouse, etc. And that's why we need to understand what is operating system. And we have already basically understood that operating system is mostly used as a program or a software which allows programs to run, and they allow program to be executed at a given point. So in that case, you'll be able to understand different execution of these processes, where the processes are supposed to be executed, why are they supposed to be executed at that time. So that's why we need to understand the function of operating system. And if you look at the function of operating system, one of them is enabling the startup application. So if you look at this, this is the startup application, and you can be able to understand the use of that. Then after that, we understand that this is the text editor, translators, editors of link, assuring that there is the right execution. The next one is the allocation of resources needed to execute programs is done. So there are many resources that are supposed to be executed, mostly input-output devices. So you have to manage, and you have to facilitate on this. Then facilitation for data compression, sorting etc. And that's why if you look at this point, if you try to right-click a folder, and maybe we assume that this is the folder that you want to right-click, it allows you to compress. So it allows you to do what you call compression. And we can still do what you call sorting. So if you right-click on your desktop, you can be able to sort, maybe either in ascending or descending order. That is now the provision that has already been provided within this point that we have here. Then plan for implementation work according to a certain criteria. So in this case, we are looking at now the efficient use of the central processing unit, and this is now the CPU, which is mostly used for execution and implementation of other programs in the execution. So if you look at that, that's why we understand that we have examples of operating system: MS-DOS, Linux, Solaris, Mac, OS, Unix, Windows, etc., that mostly are catered through the implementation of how fast it can execute within that. So we can zero and reverse and say the operating system maintain memory management, disk, maintain network, provide security, provide device drivers. Remember, this is a point that we need to understand more in the point of execution, because we have to look at now, why do we need to have device drivers in the executions? So that is why we need to look at why are we saying that this is the best operating system than the other. So in that case, that's why we need to look at types of operating system. And one type of operating system is what we call the real-time operating system. We have what you call the multi-user, single-user operating system, meaning that there is an operating system that aims in executing immediately. As we process job, it execute immediately. Multi-users is where we have many users who are executing some jobs in this execution. So in this area, that's why we need to look at now the execution of these processes that we have. And in most cases, we need to understand the form that this process is supposed to execute because it's very efficient. So multitasking and single tasking operating system. Many jobs are done by only one user. So we have many users, many jobs or single jobs that are being executed. And that's why we need to look at distributed operating system as part of other execution. So there are many operating systems that are distributed, because in this case, an operating system that manages group of independent computers and makes them appear to be a single computer is known as distributed operating system. In this case, it's like now we are using an operating system, but there are many users who are using this operating system. So they are now consolidated in one point where they can be able to work together and be able to maybe send some information within the given area. So we look at that as a distributed operating system. Embedded is when you have an operating system within another operating system. So operating systems aside from being used in embedded computer system are known as that. So that's why we implement using that. So these operating systems, they have been defined in various structures. And these are the structures that we have. One of them is monolithic structure, which was an old approach of this kind of execution. And that's why we are saying invoke simple function calls within the kernel, which one large program. Device drivers are loaded into running kernel. So you are looking at where most of the objects are communicating to each other. And they are, here we have users. We have users who are using the program, because you have the user mode and the kernel mode, where this is the right operating system, and this operating system is now able to allow the communication, but through what we call the system services. And when system services are now triggered, they are able now to trigger different objects that we have here, and they are able to communicate to each other through a hardware. That's why we use hardware like now input, output devices to communicate in that scenario. So we understand that now objects are able to communicate together. But if one object has an issue, it means that it will be able to share those issues to other computers that we have. So that's why we find that now we have various issues of communication the moment when you're talking out on monolithic. But in RAID, this is where one object must complete and the other one must proceed to that. So we are looking at this point. The service program are now setting to the system, file system, memory, process, etc. But if you look at that, we are communicating from bottom to up. So from the hardware process scheduling. So memory cannot communicate before process scheduling has already worked. Memory cannot, file management cannot communicate if the memory has not communicated. So that is now the case where we are saying these objects are able now to share some communication if you are using a hierarchy. But to improve on execution, that's why we need to understand that the best operating system uses what you call the microkernel. And when it is using the microkernel, is where we are saying the benefit extend the operating system becomes much easier. So you can extend the operating system, you can improve the functionality of this operating system. Any changes to kernel trend to be fewer. So any changes from one kernel to another, because we are having many kernels. And if you look at a kernel, is an inner core of an operating system. And if it is an inner core of operating system, it's the one that is now assisting the execution, managing processes, executing job, file management. This kernel is the one that is able to provide that. So I think we can reach at that point, but the next time we will start from languages of an operating system, so that now we can be together. And I want you to read those notes so that we can be together. Thank you.